Yes. So the next passive cooling technique is courtyard effect. So by using this courtyard effect, how can we lower down the temperature in a particular building so that we are going to get a cooling effect in our building, right? So the courtyards which are being provided in a particular building do play a major role. That is, with the help of the upliftment of the air at the same time in order to draw down the air which is at a cooler temperature, and the circulation of the air will happen from the ground surface to that of the roofs during the heat period or at the time of the sunny days, and the movement of air is going to take place from the higher elevation to the lower elevation once when the temperature is been lower down, or in a humid climate we are going to have a movement of air in a downward direction. So what is going to happen in the courtyard effect is, the courtyards that are being provided will obviously be having a sloped surface, right? And at the same time, if I am going to provide the lowered effects in the courtyard, so what is going to happen? Once when the sunlight is going to be falling over a particular building, these lowered or the stepwise hangovers which are being projected towards the courtyard will obviously be trying to alter or split the radiations that are going to enter into a particular building, right? So in that way, what is going to happen? The heat gain that is going to be happening in a particular building is going to slow down, right? At the same time, due to the orientation of a building, so what happens? If this is a courtyard provided in a particular building, and this is where is a sun is at present, okay, so what is happening? The sun's radiation or the light is going to be falling on the one side of the wall, okay, whereas this side is completely going to be in a shaded region. So because of which what happens, the shadow or the shade offered by the other side will be at a greater extent too. So what is happening? One side of a building is going to be heated up, whereas the other side of a building won't be heated up. Okay, so as this is going to fall in this direction, this side, whatever the building's wall is present, that is not going to be heated up, and that shadow will be falling over the other end. So what is going to happen? One part of the ground is cooled up, okay, and the other hand, when a hot or a heat radiations are falling over the other end of the surface, so these lowered effects are going to be reducing or cutting down the entry of the solar radiation into a building. At the same time, the hot waves or the hot radiations or the hot air which is present in the particular building will be rising up. At the same time, the wind breeze, the cold wind breeze will be moving in this direction, which is going to lift the hot air and provide a cooling effect in the interiors of a building on the other side. Okay, so in this way, what is happening? The courtyard is helping us to provide a shade on the one side, and the heat radiations are being cut down, or it is been rejected, or it is been split into many ways in order to get into a particular building. So what is happening? I am going to provide a cooling system on the one side, and on the other side the heat waves which are getting into a building or the absorption of a building is being lowered, right? So at the same time, this is happening when a hot sun is out, right, or during a sunny days. At night what happens? Once when the roof present on the either ends, or you can have a wall on all the directions also. I am just speaking about the two ends at present. So what is happening here? The roof is going to be cooling out at this level, right? Once when a sun is set, once when a temperature is going to be lowered, when it is going to be fall, during night, what is happening? The roofs are radiating the heat out and the entire surface is getting cooled up, right? That is in order to reach the equilibrium to a particular climate or in a particular region. What is happening? It is absorbing the moist air, radiating the heat outside, and then it is getting cooled. And this, what is this doing? So now the surface which was being heated in the morning will now get a cold breeze from the upward direction towards the downward direction. So the wind is going to move from the top to the bottom, and the other side of the building is going to get, not only the other side, the both side of the area is going to get a cold breeze or a cooling effect in a particular building, right? Now what is happening? In order to increase the efficiency of this wind movement or sinking of this wind movement in a downward direction, so if I am going to provide a greater steep towards the courtyard, so what is going to happen? The wind which is going to be blowing like this will be sunk inside as there is a greater slope towards the courtyard, right? So if the slope is too high, so what is going to happen? The air is going to sink inside. And it is also seen that the surface are being insulated most of the time, so that the greater amount of radiations are not being captured. Okay, so which is going to increase the cooling effect in a particular building, right? So due to the movement of the air and due to the pressure difference which is been going to be developed during the daily routine or the daily temperature changes, this phenomena is taking place, and the courtyard effect is playing a major role in providing a cooling for a particular building. So the image that is projected out, from there you can note that how the lowered hangs are being provided and how it is going to cut off or help in splitting the solar radiations for getting into a home, and how the air movement is happening, and how does the cooling is happening through your conduction and then the convection process and through the radiation process, and how during night the cooling is happening, right? And the wind movement of is in a downward direction, and how the air is going to enter into a building so that it is going to provide a cooling comfort to a particular building. At the same time, in the next image which has been popped out now, you can see here that what is happening? If a greater slope is provided towards the courtyard, what is happening? After the radiations are being emitted and the entire surface is being cooled, that is roof surface is being cooled, the major sinking of the wind is happening into a courtyard, which is again trying to spread the cool air into the buildings, right? So this is how the courtyard effects plays a major role, right? In most of the apartments and also in most of the commercial structures and in most of the educational buildings, they use this effect in order to cool a particular building. Even the shapes and the orientation or the landscape of a building is going to help in getting a courtyard effect, right? Sorry. So the next one is passive downdraft cooling. What is this passive downdraft cooling? Obviously, as the name is, so what is this passive downdraft cooling? How is this downdraft cooling happening? Yeah, so as the name itself is indicating that there is a downward drawing of a wind. So it is been draughted or pulled down, and then the cooling is happening in a particular building, right. So something is being drawn down, right. So that something is what? It is nothing but the wind which is being drawn down forcefully into a building. So this passive downdraft cooling system has got a downdraft towers, okay, which are being provided with the wind collectors, and these towers are also referred to as reverse towers, okay, where the wind is not moving from the interior to the outwards. From the outside the wind is coming inside, it is getting cooled and drawn down. That is the reason it is been called that, okay. At the same time, so in this case what is going to happen, it is like in order to have a downdraft or a wind to be moving in a downward direction, in order to make it sink in a downdraft tower, the warmer air should be lifted in the warmer towers or the other towers. When these towers are being lifted with the hot air, the downdraft of the cool air will be happening from your downdraft tower. So what is the phenomena taking place here? So these downdraft towers are being fixed with or being established or being installed with a wet cellulose pad which is being completely connected, or the water which is going to be coming out of those cellulose pads will be collected in a sump, and then the water will be recirculated using the pumps, okay. So what is happening, once when a wind collector is going to collect the air, so when the wind is going to blow into the particular tower, that is downdraft tower, the wet cellulose wet pad which are present there will be cooling up that moist air, and then they will be sinking or drawing down that air into the lower position. So this lowering down will happen, again you need to remember that the air has got this space, it occupies space, okay, but not the mass. So until and unless the air inside a building is vacated, that is air is getting out and some amount of space is created, this air cannot be drawn down. Therefore, in order to increase the efficiency of this tower, the either towers or the other towers which are being installed at a much more greater elevation when compared to the drawdown tower, and at a much of a variation in the dimension will also be present there. So because of which the hot air will be able to rise up easily and the cold air can be easily drawn down. Okay. So this is how the passive downdraft cooling happens. So the image which is present at my left, or the image which is being popped out, you can just have a look over there. At the center, the passive downdraft cooling tower is being installed, and on the either side you are able to see a warm air towers, and at the center the downdraft tower is being installed with the cellulose pad from where the water is leaking. So these wind catchers will be catching the air or placing, or it will be directing the wind into that area, and then the cellulosic pad which is wet will be absorbing the heat from there and then providing a cool to your hot air which is present, and then that will be drawn down due to the variation in the density as the density is going to increase. So what is happening, it is going to sink, and from the other two towers which are a bit of a greater elevation, which are constructed in such a way that quite good amount of air can be escaped and a good buoyancy, thermal buoyancy can be presented or can be generated in a building. So what is happening, that air is getting raised up and vacated. in order to increase the efficiency of this, it must be made sure that the hot air is being removed properly and the wind direction or the amount of wind that has to be get into your building is at a greater extent. So, which is how the efficiency of your passive down draught cooling is going to increase, right? Yeah. And this technique has been utilized from centuries in Turkey and Iran, where this has even played a very much quite good role, as well as has provided a very much effective cooling up of a building. Okay, fine. So, the next technique of cooling is, yes, so the next technique is lattice screen. It is also called as jali. Am I right? It is also called as jali. Okay. So, lattice screen is also called as jali, right? Lattice screen is also called as jali. These lattice screens are nothing but the barriers which are going to diffuse the light which is going to enter into a building, and then what is happening? A quite good amount of heat is being rejected. So, by diffusion of the light, the amount of heat that is getting into a building is being reduced, right? So, what is happening? By providing a jalis or the lattice screens, okay. So, the amount of heat radiations that are entering into a building can be cut down. Okay. So, what happens? By providing a small openings on a wall, by providing a reinforced wall, or by having a ferro cement wall, so it will also going to be decreasing the cost of construction. At the same time, what is happening? It is also providing a cooling effect. So, one more important thing which you have to note here is that during the daytime, as the sun's radiations are too high, it becomes very difficult to peep out, okay, or look through those openings towards the outer end. Okay. So, they will even be provided with the small openings at your eyesight, so which can be able to make a good visuality towards the outer environment, right? And one more important thing which you have to remember here is that along with the servicing of your passive solar cooling, though the screen is present or though the barrier is present, the amount of heat which is going to enter is there, and it is also going to provide the visuality to the exterior world, but it is also going to provide a privacy for the interiors. Okay. So, how is that going to happen? See, during the sunny days, what happens? The heat is so high and the glow of the sun is too high that from the outer or from the exterior, no one will be able to look into a building's interior unless and until the lights present inside a building is much more brighter than your sun, which is highly impossible, right? And here we are speaking about the passive solar system, right? So, what is going to happen? Obviously, the privacy is going to be generated, or privacy is going to be provided for a particular building along with the good ventilation and along with the good view towards the outer environment from the inside. Why the name Jali? Because it looks like that, and the name given Jali is by the Mughals, as most of the Mughal architects have these jalis, from where the women used to be peeping out and looking out for a particular areas outside, and also waiting for their loved ones, looking at what time they are going to come, as most of the time. Okay. So, next, So jali, that is only because only some of the openings are present over there, and as these jalis are majorly constructed or incorporated during the Mughal period, so they called it these lattice screens as the jalis. Okay. Next one. What is it? Next one? Yes, the earth air tunnels. What is this earth air tunnel going to do? How is this earth air tunnel going to help me in cooling a system? It is not only going to help in cooling a system, but also going to help in heating a system whenever required. So this technique is majorly focusing on a principle that our Earth's temperature is not the same when we go down, and it's not the same way it gets heated up in the subsurface as that when it gets heated up in the surface, right? So according to the research, it is seen that at a depth of 4 meters below the ground surface, the average annual temperature fluctuation is not too much. Okay. So therefore, what is going to happen when I am going to provide the tunnels at that depth and provide a blowers on both the ends, what is going to happen? Obviously the blowers are going to blow the air on the either direction, and if a temperature is hot in our living room or in a place or in a system, okay, or in a building, this is going to cool up the system by blowing the cool air, as the temperature below the surface is less or low, and from there what is going to happen? A cold air is going to be lifted up and the living area will be cooled up. At the same time, when the temperature in a building is dropped down, okay, so during your winters, so when a temperature in the interiors of a building is low, so here the earth's surface will be having a same temperature, like this, not as that of your outside temperature, but the annual temperature fluctuation is not too high, as well as the same temperature will be maintained at the lower elevation when in the case that of the previous days. Okay. So the total, so the overall year's annual temperature, if I am going to take the average of that, so that temperature would have been maintained at the 4 meters below the ground surface. So what is happening? The temperature here is warmer or is hotter when compared to that of the temperature in a room. So what is going to happen? The blowers which are being installed below the ground surface, okay, those are going to direct the hot air into a particular living area or a building. So what is going to happen now? Obviously the heating up of a building is going to take place, which is going to provide a comfort to a particular building when a temperature is lowered in a particular building. So it has got both the purposes. So your earth air tunnel is going to serve both the purpose, that is heating up as well as cooling up of a building on the alternate seasons or as per the requirement of a living area or a building. But here, as I am speaking about the cooling, so what is happening? So what is going to happen? As the temperature below the ground surface, so approximately at a depth greater than 4 meters, the temperature is lower when compared to that of the temperature in the living area. So what is going to happen? The wind which is being at a cooler one or which is at a lower temperature will be blown in the upward direction, and the entire system is going to be cooled up, right? Okay. So this is all about the earth air tunnels. I guess now you got to know the various cooling techniques that are being utilized in a particular building. Okay, let's have a quick brush out over our topics that we have covered till now. Okay, what are the various passive cooling techniques that we have? The first one is your shading system, right? So the shading system. In the shading system what you have? So you have both exterior as well as the interior shading system. And in the exterior system, what were the various shading systems you had? You had the eaves, okay, awnings, okay, so trees and shrubs, okay, natural cooling effect. So louvers were being used, at the same time the screens and shutters were used. What was there in the interiors? So interiors will be cooled with the help of the screens that we are going to provide, right? Right, okay. So next one was the ventilation, where the system is being cooled by the usage of the free movement of air. So what is happening in case of the ventilation? The free movement of air is going to help in cooling a system. Now here also you learned about the three strategies or the three major functions. So functionings, how the cooling will be happening. So the first one was, yes, the stack ventilation, very good. And the second one was cross ventilation, very good, and the other one was the night ventilation. I guess you remember what happened in the stack ventilation, what happened in the cross ventilation, and how the ventilation or the movement of air was taking in the night ventilation. Next, the next one was the solar chimney. Again, what is happening in case of the solar chimney? Yes, yeah, solar chimney works in the same principle as that of the stack ventilation, and you do remember that. And the thermal mass, yes, you got to know how the thermal mass were being utilized for heating, at the same time how the cooling can be done or the cooling effect will be coming by using a thermal mass or a thermal walls. Further, the wind towers, how the wind towers are effective in passive cooling and how the cooling happens, you got to know that. And the next one is the evaporative cooling system. So the evaporative cooling system, where the phenomena of the water absorbing the heat from the hot air and providing a coolness or reducing the temperature of the air, and at the same time once when it is going to absorb the heat from the air or the surrounding, the evaporation is going to happen. So therefore the evaporative cooling effect. So you got to know how the evaporative cooling is going to take place, and how you also got to know that how the interiors are being improvised along with providing a evaporative cooling effect by using the roof ponds or by the sprinklers or by the fountains or by trees and shrubs, etc. The next one was the courtyard effect, and you got to know the movement of air, and also due to the variation in the temperature, how the courtyard effect is going to play a major role in cooling a particular system, and how the effectivity as well as the efficiency of a particular building can be improved. At the same time, you also got to know about the passive down draught cooling, where the wind or the cold air is being drawn down and the hot air is being lifted up from the other two towers. You also got to know about the lattice screen, that is the jali, as the Mughal emperors as well as the Mughal architectures were majorly having this structure, and they called it as jali, hence the name, the screen, the lattice screen as jali. And what is the importance of it and how it is going to function, and what's about it. So next, so I guess the lattice screen, the image which is being projected there, from there you can see that how the jali or the lattice screen looks like, and how the diffusion of the light is taking place, and how the interior cannot be seen from the exterior when it is too sunny, and how a good visualization can be provided from the interior to the exterior environment. At the same time, it is providing a privacy. So next, in order to have a good movement of air, most of the time this jali will be provided at a bit of higher elevation at a sill or at a floor level, so that a good movement of air can be taking place, where the effectivity will be higher, where ventilation will also be in a greater extent. So earth air tunnels, you can see there the image which is been projecting out how the earth air tunnels are being installed. and how the blowers are being provided and how the air movement is going to happen, which is going to cool up a system in a particular building, right? Okay. So now let's see the various case studies which include this passive solar heating and cooling system in them. So the first one which is getting projected is the Violets at Nalanda International School, Vadodara, where it is using the thermal masses in order to have a passive cooling and heating in it. So the next one is JDT Islam campus, which is utilizing the thermal mass for the passive heating and cooling process, okay, where the thick walls provide the passive insulation and the domed shaped or the curved shaped roofs as well as the curved shaping can provide a shade to a particular area, and the arched ceilings are helping to cool the internal space of the roofs. So which is providing the alternate heating and cooling effect for a particular building in order to enhance the cooling effect in a particular building. So now you can see the Jodhpur hostel has installed the wind tower. So where the wind tower is utilized for the passive cooling up of a system where the wind is blowing or where the wind can be effectively collected at its southwest direction. So the next one, Sudha and Atom Kumar's residence in New Delhi, which utilizes the effective ventilation especially during the humid season, is providing a cooling effect to a particular building. And the Universal Business School, Karjat, Mumbai, which is being projected here, shows you the courtyard effect. Okay. The other one is from the Bewar, Rajasthan, where you can again see the courtyard effect utilized in this particular structure. And you can see the various buildings which are utilizing the landscaped courtyards, which is utilized in order to have a passive cooling system. Passive downdraft evaporative cooling being used to effectively cool the Torrent Research Center in Ahmedabad. Now let's look after the Jali effects which are being utilized in order to have a passive cooling effect. Okay. So the Jali work featured in SC Techno School, Bangalore, which is utilizing the Jali work as the passive solar cooling system. Now let's look after the other one, that is the ITM Business School, which is using the Jali work featured or which is using the lattice screen technique in order to enhance the passive cooling system. Okay. The next one is the earth air tunnels used in the composite climate of Gurgaon in retreat building.